Good afternoon everyone, my name is Trisha. I am from CSMLC section. Today our subject is data management system. From our data management system, our topic is cell association and resource partitioning in 5G heterogeneous networks. Now come to the introduction to 5G heterogeneous networks. 5G heterogeneous networks HETNET combines various types of cells including macro and small cells. Here the 5G heterogeneous networks contains it also includes that macro and small cells. These networks aims to enhance capacity coverage and user experience in dense urban environments. Understanding cell association and resource partitioning is crucial for optimizing 5G performance. In image we see that micro and pico cells in femtocells, Wi-Fi macrocells. What is cell association? Cell association refers to the process of determining which cell a user equipment UE your user equipment connects to. It plays a crucial role in managing networks resource and optimizing user experience. Factors influencing cell association include signal strength, load balancing and user mobility. Now the resource partitioning overview. Resource partitioning involves allocating networks resource among different cells in a HETNET. Efficient resource partitioning ensures that all user receives adequate Efficient resource partitioning ensures that all user receives adequate service quality regardless of their location. It helps in minimizing interference and maximizing throughput in multi-network environment. Now I can see that in the image, sales, there are three different types of sales. From first picture sales, it's looking like a calendar, right? And from first to second sales, there is January and February. There are single. In first picture, there is a sales in single picture. In sales, there are two types, which is January and February. And second sales in January we have two types, and in February we have two types. And that one type in January EMEA, and second type is APAC. In February, one type is EMEA and second type is APAC. Types of cells in HETNETs. HETNETs consist of macrocells, microcells, picocells and femtocells. Here net cells have the microcells, picocells, macrocells and femtocells. Now we can clearly observe that HETNETs contains very small cells, because microcells and picocells, femtocells are very small in the size. Each cell type serves different user densities and coverage requirements. Understanding the characteristics of these cells is vital for the effective network planning and management. Now the benefits of cell association. Proper cell association can enhance spectral efficiency and reduce latency for users. It allows for the better load balance across the network, preventing congestion. Improved cell association strategies can lead to an overall better quality for service QoS for end users. Challenges in cell association. The dynamic nature of user mobility poses challenge in maintaining optimal cell association. Interference from neighboring cells can complicate an association process. Algorithms need to adapt to changing networks conditions and user demands for the effective association. Resource partitioning techniques. There are several techniques for the resource partitioning, including fixed dynamic and statical methods. Dynamic resource partitioning allows for the real-time adjustment based on the network's conditions. Statical method predict resource needs based on historical data and user pattern. With the load balancing headnets, load balancing is essential for the ensuring that no single cell becomes overloaded with traffic. Effective load balancing strategies can optimize the use of available resource across multiple cells. This process improves overall network performance and user satisfaction. Now the impact user density. User density significantly affects cell association and resource allocation strategies. High user density may require more small cells to ensure sufficient capacity and coverage. Understanding user distribution helps in planning effective cell layout and resource allocation strategies. Now the algorithm for cell association. Here now the algorithm for cell association. Various algorithms exist for cell association, including threshold based and utility based approach. These algorithms aim to optimize the selection of the best cell based on the user requirement and network conditions. Continuous advancement in algorithm is crucial for adapting to evolving networks demands. Interference management. Interference management is critical in headnets to maintain service quality. Techniques such as interference cancellation and power control can mitigate adverse effects. Effective interference management contributes to better cell association and user utilization. Further trends in cell association, the integration of artificial intelligence and machine learning is shaping for future cell association strategies. Predictive analysts can enhance decision making in real-time network conditions. Further trends will focus on the automated and self-organizing networks for improved efficiency. Case studies in headnets. Several developments around the world demonstrate successful cell association and resource partitioning strategies. Case studies highlight the importance of the tailored approach based on specific urban environments. Lessons learned from these case studies can guide for future network planning and optimizing. Now we can again say that the algorithm for cell association is it exists offers cell association, and it has various algorithms, and includes the threshold based, and it is optimized the selection of the best cell based. The impact of user density is affect this cell association and resource allocation. High user density, the in load balancing is there is no signal, cell becomes overloaded with the traffic. Here the resource partition techniques. There are techniques resource partitioning include fixed, dynamic and statical methods. It all are the techniques for the partitioning. Here the challenges in cell association: adapt changing network conditions, and mobility poses challenges, maintaining optimal cell association. The benefits of cell association is can enhance spectral efficiency. Now we come to the conclusion. The conclusion: cell association and resource partitioning are vital components in the success of 5G headnets. Here the cell association and resource are both are very useful to success the 5G headnets. Ongoing research and innovations are essential to overcome challenge and improve network performance. Here the ongoing research and innovations are very helpful to improve these network performance. A comprehensive understanding of these net concepts will lead to enhanced user experience and network efficiency. So we can easily say that cell association and resource partitioning is the success for the 5G networks, and ongoing searches and innovations are helpful to improve the network process. Thank you.